Okay, here we are in section 3, looking at tests for parallelograms. How can we know that something is a parallelogram? What are the qualities that will guarantee that that has to happen? So let's take a look at the parallelogram, or the quadrilateral that we have here. We have a quadrilateral, and one pair of opposite sides are both parallel and congruent. So is that a parallelogram? Well, we've got the one side of pair of parallel sides, but are the other ones parallel also? And if we take that and we draw in a diagonal, have you noticed that a lot of diagonals come into play in this chapter? Then we see that these two angles are congruent. And we know that, of course, the diagonal is congruent to itself. So we can know then that the triangles are congruent. And so if the two triangles are congruent, then we have that angle 3 here and angle 4 are congruent by CPCTC. And therefore, the segments are parallel because of alternate interior angles. So there's a quick informal proof of, yes, we do know that that is a parallelogram then. So there are certain properties in a quadrilateral that tell us it's a parallelogram. There are certain properties that tell us something is a square, or that tell us that it's a rectangle. But what are the properties that people should see in us if we're a Christian? And so we want to kind of think about that idea and see, can you think of some verses that talk about how people will know that you're a Christian? So what other properties are found in a quadrilateral that would suggest that it's a parallelogram? Okay, so a little hint here as to things that we might look at. What are the properties of a parallelogram? If we see those properties in a quadrilateral, do we know that it has to be a parallelogram? So, theorem 8-9. If both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. We'll be looking at some proofs in the homework and possibly outside of the homework on several of these theorems. And pretty much the proofs comes down to putting in diagonals and proving congruent triangles and working with them that way. Theorem 8-10, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so if the opposite sides are congruent, it's a parallelogram. If both pairs of opposite angles are congruent, it's a parallelogram. Theorem 8-11, we know that the diagonals of a quadrilateral or of a parallelogram bisect each other. So does the converse work? If we have a quadrilateral and the diagonals bisect each other, then that has to be a parallelogram. And theorem 8-12, if one pair of opposite sides are both parallel and congruent, then it's a parallelogram. That was the example that we started off with and looked at the informal proof of. So can you draw an example of each one of those? Take a minute to draw an example of what that would look like for each of theorems 8-9 through 8-12. So for theorem 8-9, we would be looking at a figure, and it says both pairs of opposite sides are congruent. So if we mark these sides congruent and these sides congruent, then what do we know about that figure? It is a parallelogram. For theorem 8-10, it says the opposite angles are congruent. So marking the opposite angles congruent. If we see that, we know by theorem 810 that that's a parallelogram. If the diagonals bisect each other, so put in both the diagonals, and the two halves of that diagonal are congruent, two parts of that diagonal congruent, then we know that has to be a parallelogram. And the last one is the same thing we saw at the beginning. We have one pair of opposite sides, both parallel and congruent. And that has to be a parallelogram. So using that information, look at each of these diagrams and determine if it has to be a parallelogram. Pause the video here while you write down your answers. So in the first one, you should have determined that that is a parallelogram because the opposite sides are congruent. Number 2 is a parallelogram because one pair of opposite sides are both parallel and congruent. Number 3 is a parallelogram because the opposite angles are congruent. Number 4, we don't have enough information because the sides that are parallel and congruent aren't the same sides as they were in number 2. Number 5, we see that the diagonals bisect each other. Therefore, that will be a parallelogram. And number 6 is not a parallelogram because it's not the opposite sides that are congruent, it's adjacent sides. Back to our algebra a little bit on this section as we look at what would have to be true for these to be a parallelogram. So in A, we see we have one pair of sides, opposite sides that are parallel. So if those are congruent, then we know it would be a parallelogram. So we would set up the equation, well, 3 times the quantity x plus 2 has to equal 4x minus 1, and solve for x. In B, we have one pair of opposite angles that are parallel, that are congruent, not parallel. And so the other pair of opposite angles need to be congruent also. So we would have 5y plus 28 equals 6y plus 14. And solve for y for that to be a parallelogram. And in C, we know the diagonals have to bisect each other. So the 5y has to equal 2y plus 12. Note that y being that value would not be sufficient to make that a parallelogram because we don't know anything about the other diagonal. Okay, a little bit of coordinate geometry here as we look at determining if this figure is a parallelogram. And there are several ways you can do this. They're telling us here to do it by the slope formula. This could also be done using the distance formula to show that opposite sides are congruent, or using the midpoint formula to show that the diagonals bisect each other. But using the slope formula, we're just going to basically use the definition and find the slope of each side of the parallelogram. So the slope of segment AB would be 3 minus 0 over negative 1 minus negative 3, or changing that to plus a positive, 3 halves. And if it's a parallelogram, we know the slope of CD should be the same. So there we have 2 minus negative 1 over 3 minus 1, which is again 3 halves. We have one pair of opposite sides parallel. The slope of BC is 3 minus 2 over negative 1 minus 3 is negative 1 fourth. And the slope of AD, we have -1 minus 0 over 1 minus -3, which is, again, -1/4. So opposite sides are parallel. Therefore, this figure is a parallelogram. This problem is telling us to determine that this is a parallelogram by using both the distance and slope formulas. So that's suggesting that we're going to show that one pair of opposite sides are both parallel and congruent. So let's do the parallel first. And I'm going to pick QR and PS. So if we find the slope of QR, that's going to be -1/2 over 1/2=3/4. So -2 over 4 or -1/2. And the slope of PS, I'm not using the formula right now, though you would be to show me the work for that. And that is also -1/2. Finding the length of each segment then, we have the distance from Q to R is given by the distance formula. So we have 16 plus 4, or the square root of 20. So 2 radical 5 for the length of QR. And plugging in the values to the distance formula to find distance from P to S, we have then that also works out to 2 square root of 5. So we have one pair of sides that are both parallel and congruent. Therefore, the quadrilateral is a parallelogram. The homework was at the beginning of the section, so you can go back to the beginning of the video if you didn't get that written down then.